Hello, ladies and gentlemen, welcome back. Root Beer here with question number 8 on the Pascal competition from the year 2003. So, what does question 8 have to say? What is the area of rectangle ABCD? They're referring to this rectangle over here. So we've got a rectangle and it's on the Cartesian plane. And we've got some of the coordinates. Not the coordinates for A, but we know that D is at 4, 5. C is right below it at 4, 2. And B is just across from C at -1, 2. Okay. So we want to know the area of the rectangle. Well, we got to start thinking of ways to get the area of the rectangle. And we think about it, and there's really only the one way that anyone ever comes up with for the area of a rectangle, and that's length times width. So we take a look at this rectangle. Can we figure out its length and its width? Well, you bet we can. For example, we know that C is right below D, and the difference in their y-coordinates is 5 minus 2, that's a 3. So we're going to have a height of 3 on this rectangle. Similarly, we can get the difference between B and C. They're up at the same height, they got the same y-coordinate. So the length between B and C is just going to be a difference in their x-coordinates. And that will give us the 2 dimensions of the rectangle. We've got B over here, and then we've got C. D is up a little bit. We've got A over here. We don't have any coordinates for A. And that's okay. We're not going to get coordinates for A. If you wanted some, -1 and 5 would be the coordinates for A. But we don't need those. So this length here, CD, well, that's going to be the difference in their y-coordinates, 5 minus 2, 3. And this length here, BC, well, B and C are both of the same height. So you could apply a distance formula if you know it, but really, it's just how many units from -1 up to 4. Well, it's a difference of 4 minus -1. 4 minus -1, that's really 4 plus 1. That's 5. So ABC is a 5 by 3 rectangle. Its area is, well, 5 times 3. Which is going to be 15. Okay? If you had graph paper, and I know I do have graph paper, but I often don't exploit the graph paper. If you brought graph paper to your exam, and I do encourage it, you could have very nicely and neatly drawn some axes and given each square was sort of a 1-unit square, and you could have plotted these points and actually just counted up how many little squares were in there. I could have done it if I'd been accurate, and you would have gotten 15 as well. Okay, so that's another way you could do it if you brought the right tools, the right props to your exam. Okay. 15. Where is 15 on our answers? Ah, it's the first one. So we're going to go with A. All right. Not a bad little question. In fact, it's shaping up to be not a bad little contest. We're going to take a look at question 9 in the next video. Thank you guys for watching. If you'd like to, feel free to subscribe to be kept up to date. And, of course, throw a like on the video if you've enjoyed seeing the solution. But either way, question 9 is coming up.